Kia ora koutou. This is a pretty quick video going over iterative methods, and it's based on chapter 8F of the textbook. Now 8F is an integration exercise where we're mixing up all of the different techniques. But in this particular problem, you have to go on and use some stuff from chapter 6. Okay, so the reason for that is that we're given an equation. I'm hoping my stylus is going to work. Yep, it is. And the equation is this one here. So 2 plus e to the negative x over 2 is equal to x. And if you look at that and think about it, we can't solve that using our standard algebraic methods, right? You can try like rearranging and then taking logs, but you're still going to have x on both sides of the equation, right? So when this happens, what we're going to use is a method where we're going to iterate around and get to an approximate solution. So the first thing we're going to do is we're going to show or verify by calculation that there's a root between 2 and 2.5. So to do that, I want us to think about the left-hand side as being one function, f of x is x, and g of x is equal to the right-hand side, which is 2 plus e to the negative x over 2. I've graphed both of these here. So we can see on this graph that we've got a root that is happening somewhere just above 2, which fits with the question, right? So this one here is g of x, and this is f of x. There are two ways to do this first bit. The first way is to look at the value at 2 of f of x and look at the value of g of x. And you can see that f of 2 is greater than g of 2. Now, we have to actually go and show this and do some work, but this is the idea, right? And then at 2.5, which is out, I don't know, somewhere here, we can see that it's switched over and f of x is less than g of x. So that's one way we can do it. The other way is just to set up a new function, and this is quite common notation, is to write this new function as the left-hand side one minus the right-hand side one. So in this case, what we get is x minus 2 minus e to the negative a half x. And if we evaluate that at 2, then we get 2 minus e to the negative a half times 2. And that gives me negative 0.368, which is less than 0. And if I evaluate the function at 2.5, I get what? I get 2.5 minus 2 minus e to the negative 1.25. And if you work that out, you get 0.2135. And that's greater than 0. So what's going on here? Well, my function here is continuous. So that means that there must have been a place in between 2 and 2.5 where we went through 0. And that is the definition of a root, right? So a root happens when f of x is equal to g of x, which means that we need big F of x is equal to 0. So when we're doing problems like this, if we can show that on one side we've got a positive value for big F of x, and on the other side we've got a negative value, then because the function's continuous, somewhere in between there has to be a value that is going to make it equal to 0. So I've drawn a picture of this over here. This is f of x, big F of x here, right? And you can see that f of 2 is giving me my negative 0.36 value, and f of 2.5 here is giving me my positive value, right? And this function's continuous, so there's a crossing point somewhere in between those two values. Now, there might be more than one crossing point, but all we care about is that there is a crossing point, and that's a root. So what we need to say here is, since f of x is continuous and we have a change in sign from x equals 2 to x equals 2.5, there is a root, and we'll call it alpha, between 2 and 2.5, right? So it's really important when you're showing your working here that you clearly show that you get that this one is negative and that this one is positive. Okay, so that's the way that I prefer to do these questions, is to set up a big f of x function. It's, as I set up here, it's fine also to work with the two individual functions, right? One function for the left-hand side, one function for the right-hand side. If you're going to do it that way though, just make sure, so if you're doing this function here and this one here, make sure that you're showing that it's greater than one way and less than the other way. Okay, that's the first part of the question done. Something weird is happening with my stylus. Let's have a look. So we've verified that there's a root, and then we have to use an iterative formula based on this equation to calculate the value of the root to 2 decimal places. So just going over what we're going to do here, we're going to have an updating rule. And we need to take the original equation that we've got and somehow make x the subject. But in this case, it's already got x the subject. So this is a really easy example of how to do this method. So we're going to take an initial value of x, and we're going to call that xn. And we're going to put it into g of x, and we're going to see what number we get out, and that's going to become my next value of n. Right, for example, if I put in, if I start at 2, I put in 2, and my new value of x is going to be this one here. So this comes out to be 2.36. I'm going to bounce across to here. I'm going to bounce up to here. Then I'm going to bounce across to here and up to here, and I'm going to converge on that root. Now that's a really bad diagram of it. If you look at the PowerPoint that I used when I was teaching this topic, that's on Google Classroom, you'll get a better idea of how that picture works. It's also explained really well in the Pure 3 textbook. So what we're going to do now is we're going to use this formula to calculate the value of this root. We have to show that we're using that iteration, and we have to go to 4 decimal places each time. So this is kind of boring, but it's not that hard. So this is my starting value here, xn. So we'll start with x0, and I can just pick a number. I'm either going to pick 2 or 2.5 or 2.25, but I'm kind of lazy, so I'll pick a nice easy number, which is 2. I'm picking 2 because it's somewhere close to where my root will be. So xn plus 1 is equal to 2 plus e to the negative x over n over 2. So substituting that in, we get 2 plus e to the negative 2 over 2, and that gives me 2.3679. Okay, so this becomes my new value. So x1 will be 2.3679. I put that into here, and I get 2 plus e to the negative 2.3679 over 2, and that's 2.3061. That's my new value over here. Now I get 2 plus e to the negative 2. You get the idea, right? I'll just stop talking. But I am going to say I'd like it if you could show a few of those. I think once you've done 3, you've pretty clearly shown that you get what's going on. So what I'm looking for now is convergence to 2 decimal places. So I'm looking at these x's, and I'm saying, when am I not changing if I just go to 2dp? So this one here is 2.37. and this is 2.31. So I'm clearly still changing. When I get to x3, I've got 2.32. So we need to do another one. And we get out 2.3142. So x4 is equal to 2.3142. So I'm still changing a little bit, right? Because here I've got 2.32 and here I've got 2.31. So I need to do another one, 2.3144. And you can see that now we've got x5 not moving when I go to 2dp. So 2.3144 is now matching up to the one above, right? So that's showing me that to 2 decimal places, we've found my root, and it's a is equal to 2.31. So there you go, Theo. I hope that helps. I've done about 3 other videos on iterative methods, and they're all slightly different. This one is easier than usual because the formula, the updating formula here has already got x being the subject. So if, for example, I had instead 3x plus 5 is equal to, I don't know, 2 plus e to the negative a half x, then what I would need to do is to make x the subject. I've got a couple of choices on how to do that, But with this one, I would probably go 3x equals, well, this would be a really silly one, right? Because I've got this and this. I'd have 3x equals -3 plus e to the negative a half x. And then I'd get x is equal to -1 plus 1/3 e to the negative a half x. Now that feels really weird, right? Because I'm solving to make x the subject, but I've still got x stuff over here. But this is how I want to end up. So my iterating formula for this example would be the new one is equal to -1 plus 1/3 e to the negative a half times the old one. And in equilibrium, or when we've found the root, what we've got is that x n plus 1 is very, very close to xn. Okay, so now I really am done. Please send me an email if you've got any questions on this one or on anything else. Thanks for watching.